Hey guys, all right, so a couple things here. This is due today, so I'm going to go through this really quick. Then I'm going to do a couple of regents table G problems, and then later, not in this video, if I have time later today, I'll go over reference table F, which is a new table. So here we go. So this was due today. And all right, so table G, here we go. And I could probably zoom in a little bit. There we go. All right, so what type of solution will be formed if 45 grams of KCl are dissolved in 60? Okay, so 60 degrees, 45 grams right here. And KCl, pretty much right on the line, saturated for number one. 2, what type of solution will be formed if 70 grams of NH4Cl at 80? Okay, so 80 and 70 puts me here. All right, so 80 and 70 puts me here. That is above NH4Cl, so super saturated for number 2. Number 3, 100 grams KNO3, 60 degrees. 60 degrees, 100 grams right here. I am underneath KNO3, unsaturated. 4, how many grams must be dissolved in 200 mils at 40 to make saturated? So again, 200 milliliters is double whatever's on here. So I'm going to go to 40 degrees and then up to NaNO3. 40 degrees up to NaNO3 right here. Saturated is on the line. That's about 105, right? 105. So in 100 milliliters at 40 degrees, saturated solution is 105 grams of NaNO3. Question wants to know 200. So if it's 105 grams in 100 milliliters of water, 200 milliliters of water, you would double 105. So that's 210. 210 grams for number 4. Number 5, 50 milliliters of water. So this chart takes place at 100. So I'm going to look up 10 degrees for Ki and then cut it in half because 50 is half of 100. So 10 degrees Ki, that's way up here. So that's about 135, 136. Say 136. So 136 at 10 degrees is saturated, but that's 100. So half of 136 would be what? 66? What did I say? 136. So 136, half of that would be, no, 68. Yeah, 68. 68 grams is the answer to number 5. That's half of 136. Okay. If a saturated solution of KClO3 at 80 is cooled to 60, how many grams will precipitate? This is what we did the other day. I did in a video. This is a more advanced. I thought there were more advanced questions here, but 6 and 7 are good. So, all right. So we're at KClO3, and we're at 80 degrees. KClO3. Oop, where am I? Right here, this line. 80 degrees, KClO3. That is, I'm going to say 44 grams. So 44 grams at 80. And then we cool that same solution down to 60 degrees. So 60 degrees, follow that line down, and that's about 20, I don't know, let's say 28. So at 80 degrees, saturated KClO3 would be 44. So we have 44 at 80. We cool it, the solution can now only hold 28, right? So if at 80 degrees, come on, 80 degrees was 80 degrees Celsius, it can hold 44 grams. At 60 degrees Celsius, it can hold 28 grams. All right, so we just did that on table G there. Subtract that, because all of this is in the solution. If you cool it down to 60, that's still in the solution. However, water at 60 can only hold 28 grams, can only dissolve 28. So that extra will precipitate, fall to the bottom. 44 minus 28, 16 grams. That's how much will precipitate out of solution. That is number 6. All right, number 7. 50 grams of NH4Cl are dissolved in 100 milliliters of water at 60. How many additional grams must be added? All right, so 50 grams at 60 degrees and 50 grams. We want to get up to NH4Cl. So we're at 60 and 50, 60 degrees, 50 grams. I'm going to have to add about 7-8 more grams. 7 or 8 additional grams to go from here up to here to be saturated. So I would say 8 grams plus or minus, probably 7 grams plus or minus 2. On a regents, they would take anywhere from 5 to 9 probably. So there we go. So that's number 7. How much time did that take? All right, good. All right, I got 2 reference table problems that you can see here for table G. So here we go. If you look at number 42 here. Hey. Why does it keep doing that? All right, so that should be good. Yeah, all right. So 42, at standard pressure, what is the temperature at which saturated solution of NH4Cl has a concentration of 60 grams in 100 grams of water? So basically, we're going to go to table G. We're going to look up 60 grams. The 100 just means you can use table G, 100 grams of water. That's the amount of water. So we're going to go to 60, and where that touches the line, we're going to drop down and see the temperature. So 60 grams. I should have, you know what, I should get my reference table out. That's all right. So we want to know what temperature is it saturated if it holds 60 grams. So we go back to this. So NH4Cl, 60 grams right here. It is saturated right there. So now at 60 grams, that's saturated. Drop straight down. And that's like 66 degrees. So let's go back now. There it is, number 1, 66 degrees. All right, and one more. June 2011. Number 36. There it is. Which compound becomes less soluble as temperature increases? That's one of the lines going down. Less soluble as the temperature goes up. The only 3 are HCl, that goes down. NH3, that goes down. SO2, that goes down. Why? Because they're gases. And gases want to be cold, like penguins, huddled together to stay down, stay dense, stay in solution. So HCl, NH3, SO2 are the only 3 that decrease solubility. So that's what this y-axis, decrease solubility as temperature goes up. So it's got to be one of those 3. And HCl, there it is, number 1. So I'm going to stop the video. That's 2 regents problems there that are very similar to what we've been doing. We're done with table G. I hope you guys are making sense of this stuff and watching these videos, doing the work. I mean, I'm keeping track of who's doing the work through Google Classroom, but, you know, this is the best way I can do it. Unless we do a Google Google Meet. But even then, you know, I would need everybody, you know, to make sure you're all getting it. And that's not going to happen. I know that. So, you know, hopefully you guys are paying attention, watching these videos, doing the work. So that's table G. So Monday we'll do table F. And I don't think I'll have time later today. My wife has stuff that she needs to do, so I got to watch my daughter. So I think I'll get to that Monday. All right.